Okay, so as I mentioned, today we're focusing on transformations. That's like the translations, rotations, dilations, all that jazz. The first one right here, it says given a pre-image and an image, that's just the standard. And then it says quadrilateral PQRS prime is a translation of quadrilateral PQRS. What is the translation rule? So remember the one with the little marks right here is the prime one, and that's the second figure. So you're going from the original to the new one. What you would do is just choose a point. It doesn't matter which one. It just has to be the same corresponding point on the other one. So I might choose R and R prime. And I need to understand what the movement is here from this one to this one. So it's right or left first. So we're going to go to the right. From -3 to 7 is 10 units. So that'll be plus 10 because you're moving to the right 10. And then it'll be up however many units that is. So from -1 to 8, that's plus 9. And because it's going up, it's plus 9. So it's going to the right 10, up 9. So how we would write this as a translation rule is xy becomes x plus 10, y plus 9. And this is what you'd be looking for as an answer. And it wouldn't matter which point you chose. If I chose Q to get from Q to Q prime, I should still be moving over 10 up 9. So it doesn't matter which one you choose. Okay, next question. We're moving down to 11. It says the quadrilateral LMNO is reflected over the x-axis. What is the translation rule? I believe this is supposed to be transformation rule. Transformation. So they're looking at how the points change when it's reflected. So again, just choose one point. Like I'm going to choose N and N prime. N is at -2, 1. And N prime is at -2, -1. So when it's reflected over the x-axis, the x is staying the same, and then the y is changing to the opposite sign. So as far as my rule, xy becomes x -y. So you could memorize that rule, but why memorize it when you can just figure it out? Okay, so that would be the answer there. Number 12. What rotation is shown for the dashed triangle to the solid one? So I'm going to zoom out so we can see the picture. Here's the picture over here. From the dashed to the solid one, and it does show the prime right here. So, okay, that's the second one. So it's going from here to here. Some of you might be able to see that right away. It's like a 90-degree turn this way. Remember, counterclockwise this way is a positive rotation, and clockwise is a negative rotation. You might be able to eyeball that there, but if you couldn't, then what you can do is just choose a corresponding point. In this case, I'm going to choose B and B prime. And then draw a line to the origin, because it's being rotated about the origin. And that is your angle of rotation. So this looks at about 90 degrees. So our rotation is positive 90 degrees. So positive 90 degrees or negative 270 degrees. Remember, there could be select all, and this is a case where it might be select all. Okay. 13. What types of transformations result in congruent figures and which do not? I've been assigning this a lot on Khan Academy. So the ones that make congruent figures, congruent, would be a translation. For a translation, you're just sliding it to a new spot, like the two shapes are still congruent. Rotation, shapes stay congruent, and reflection, they stay congruent. The one that does not stay congruent, so not congruent, would be dilation. Dilated figures are similar, but they're not congruent. So far, pretty easy, yeah? Okay, number 14. Which of the following transformation maps the regular pentagon shown here on itself? Okay, so it's saying if it's rotated about the center, how many degrees would you have to turn it for it to land on itself again? So the way we did this is, okay, so a full turn is 360. You can divide that by the number of times it would fall on itself. So we have how many corners? 1, 2, 3, 4, 5 corners. So we divide by 5 and get 72 degrees. So a 72 degree turn would map it onto itself. I interpreted this question a little bit differently. Which of the following transformations maps it onto itself? I was thinking, okay, 72 degrees, it would also fall on itself again at 144. Add another 72, whatever that comes out to, it would also map onto itself again. So I was thinking of this as like a select all, but then when I looked at the answer choices, 72 is the only one that works. But technically it would map onto itself for all the other turns as well.
Bless you.
Okay, next page. Given the sequence of transformations, give the sequence of transformations that will graph quadrilateral ABCD to EFGH. So ABCD is your first, and then this would be your second. Okay, it looks like a translation. So what we can do is just choose two corresponding parts. Like I'm going to choose A and E, they look corresponding. And I'm going to see how I need to move this to get it to my second figure. So right or left first, so I'd go right and then down. So it goes to the right 4 units, so that would be +4, and then down 4 units -4. So this would be pretty easy. Okay, next one. Give the sequence of transformations that will graph triangle ABC onto triangle PQR. Okay, so ABC is the first one, the original, and this is the second one, the new PQR. Okay, so it wants a sequence, so it's talking about more than one. How would you get this onto this one? Well, we could rotate it. We could rotate it 180 degrees. Oh wait, it would be the other way, sorry. So it's going from 1 to 2, so this way, 180 degrees. But then look how this isn't quite on. This is at -1, -1. This one isn't quite at 1, 1. It's over like just a smidge, like a half. So here's how we're going to rate this. So step 1, rotate ABC 180 degrees about the origin. This could be rotated either direction because 180 degrees, whether it's clockwise or counterclockwise, will be in the same space. So either direction. That'll put it right here at 1, 1, and then we have to translate it like half a unit to the right. Step 2, translate ABC 1/2 unit to the right. Or you could write that translate x plus 1/2. And again, it would be multiple choice, so if this is multiple choice and there was like 4 different answers, I'd just go through each answer choice and follow the steps and see if it maps onto the second one. Okay, 17. 2 triangles on a coordinate plane are shown. Got it. What transformations could be applied to map triangle EBD onto CBA? So EBD, so this is our number 1. This is our number 2. It's going from this one to this one. Option 1. To get from this to this, we could rotate 180 degrees. Rotate 180 degrees. Either way, too. So you could also rotate it 180 degrees that way. Option 2. The other option would be you could reflect this over the x-axis to get it right here, and then you could reflect it over the y to map it over here. So option 2 is reflect over x-axis and then over y-axis. Or vice versa is what it said in the answer key. So you could reflect it over x, then over y to get that. Or you could reflect it over y and then over x to get it into that spot. Oh yeah, you could reflect, no, well, so you're saying you reflect it over here, but then it wouldn't quite be in the right orientation. But good thinking. That isn't on the review, but that's something that they might try to challenge you with on the exam. Remember, there's that reflection over the y equals x line, or y equals negative x line. Part B, it says, once the transformation is completed, how can you determine if two triangles are congruent? It would, like, land on itself. That would be one way. The answer key said you can determine if two triangles are congruent because all the angles and all the side lengths would be congruent. You could also say, like, it'll all line up. It'll land on top of the other one. Okay, next one. Actually, this is the last one we're going to do today. What translation rule and dilation scale factor centered at the origin justifies that the large triangle is similar to the small one? Okay, well, if these are similar, then I should be able to map it onto this and then dilate it, and it should land on that shape. So what would we need to do that? Well, first of all, we'd have to move this over here so the x's line up. So I'm going to go here and here. Okay, so it's to the right, 1, 2, 3, 4, 5, 6. So plus 6, up 3. So step 1. Translate x plus 6, y plus 3. And then once we have that, so this guy would be right here, it'd be like right here. Okay, so now we have to dilate it so it fits onto this thing. We want to find the scale factor. What I would do is just use one dimension of the shape, one that you can count. So here I can count this is 3 units, or I count this as 3 units. And then from here to here, from -5 to 10 is 15 units. So 3 to 5. So times 5 or divide by 5. How do you know which one to do? Well, remember scale factor is new over the original. In this case, the new one is the big one. It has a little the prime symbol. So the new one is 15 and the original is 3. So divided by 5, we get 5. So step 2, dilate by a scale factor of 5. And we're done. Okay, I still need to do one more thing to set up the homework. I just need to put the questions in the homework. It might take me a second, but I know it'll take you a second to get logged onto the computers anyway. So you can get up, get a computer, get logged onto Schoology, and I will set up the homework.